Hi everyone, welcome back to the workshop, and today I'm going to kick off a new project, and this is one I've been looking to do for quite a long time. I have a voltage source, a homemade voltage source that I've been using for a couple of years now. Just a little analog 0 to 10 volt, min and max and all the rest of it there, which I've been using on a few of my different projects like the power supply project over the past couple of years. And I thought it was time I had something a little bit more accurate. You know, this thing's down to maybe 10 millivolts resolution, something like that. So I need something a lot better than that. So I thought I'd actually push a bit further and make something really accurate if I can possibly do that. So I'm going to make myself a digitally controlled one. It's going to be Arduino powered as ever, and it's going to have a really nice stable voltage reference in it and a nice digital LCD. So let me just take you down onto the workbench here and show you the parts I've assembled so far. So here's the enclosure I'm actually going to use. It's a smaller enclosure than the original analog one I started out with, but it's still got the battery compartment at the back, which I'm going to make use of. But yeah, it is a little bit, it's not as wide, it's about the same height, maybe a little bit shorter in height, but yeah, it's not quite as wide. And I've got a few extra parts. I've got a nice keypad here. This is a keypad that I basically used on the bench power supply, the home bench power supply that I made, so it's exactly the same type and all the rest of it, so I'm going to make use of that there. I don't really want to put a pot on a nice stable voltage source like this. I want to be able to dial in a voltage right down to the highest resolution on the keypad there, and it'll output. So, you know, since I've got a nice keypad there, I thought, well, I'm going to go with a graphics LCD. So this little LCD is basically the same technology and resolution that I used on the power supply project as well. It's an SPI interface on it, so I'm actually going to make use of that there. Same resolution, so I have actually powered this one up on a breadboard and got it working, so I know it is exactly the same. Then other than that, I've got a couple of banana sockets there that I'm going to put on the top here. However, when I'm going to be designing and building a really stable accurate voltage source like this, I thought, well, I really need a couple of other pieces of test equipment that I can use to measure and to test the accuracy and troubleshoot the output and all the rest of it when I'm actually building this up and designing it. And I don't really have, you know, a lot of that kind of highly accurate test equipment, so I have actually bought a couple of extra items, so we'll just go to them now. So the first thing that I've bought, I bought a nice second-hand Keithley 2015 THD. It's a 6.5 digit bench multimeter. So that seems to be working okay. I might stick it away and get it recalibrated just so that I know it's stable and all the rest of it and accurate and all that kind of thing. So that takes care of the multimeter. But the other thing I'd really like to have so I can do some proper testing is actually a proper voltage source, a calibrated voltage source. So I have actually managed to pick one up on eBay. And here it is. It's an EDC model 501J, or the back end of it anyway. This is a voltage standard. That's what I've got. So let's turn it around and have a look at the controls in the front. There isn't any. Oh dear, what we're going to do? Well, actually, this is the next project that I'm going to be getting on with. The voltage source is going to follow after I've gotten this thing the way I want it to be. So here it is. So what you've actually got here, it's obviously a rack mounted, a 19-inch rack mounted version of the EDC-501J, and it's a programmable DC voltage standard. What I think they really meant to say with this thing is it's a remote programmable DC voltage standard, because on the various versions that we've got, if I can just pick up the manual for it, you can see you've got quite a number of switches on the front there for operating it from the front, but they do actually do, as you can see here, a headless version of it, a remote programmable version. And if I turn it round, you can see on the back there's a couple of edge connectors there, a data input A and a data input B. What you can do there is the controls for dialing up the voltage that you want, you would actually do via remote TTL inputs on the back here. So I'm actually going to make use of those inputs and to provide to design and build my own front panel. So actually, I can just turn it around again. What I'm actually going to do is retrofit a bunch of controls onto the front here. So I have actually been assembling a number of parts up ahead of receiving this unit, which I bought on eBay, by the way. First thing I'm going to do is I actually want to fit an LCD in the front. So I've found this rather nice, quite large digits, a 9mm character height, a 2x16 I think it is, LCD. So that's going to go in the front there, and that's going to display the voltage that's the user selected there. I thought that'd be nice to have in the front. Arduino Nano powered, that's going to go inside. A bit of Vero board there for putting all my electronics on. And then I've got two choices. Right at this very second, I'm not exactly sure what sort of controls I'm going to have in the front. I've got two options really. I've got a bunch of these rotary switches that I can put in the front, 10 positions, so that gives me my 0 to 9 on the front. I could probably put 6 of them along there and interface that to the Arduino. Or probably what I am going to do, if I can just open this up here, I've got a bunch of these push button switches, they're exactly the same type that I used on the bench power supply. I can put a series of them along the front, and what I was thinking of was something like an up and a down for each digit on the LCD effectively. And so you'll basically have 6 columns of them along the front there, 2 per digit along there, and there'll be a couple of other ones for there's a couple other mode switches that you actually need. There's a range select and that sort of thing has to go in the front. So I'm probably going to go with that. There is a couple of reasons why I'm going to do that. I think maybe the rotary knobs, maybe a little bit old school, and I don't actually need the rotary knobs because I don't need to see round the dial effectively which what I've got to select to do, because the LCD is going to do that for me. So it'd be nice just to have the push buttons just to do that, so along the front there. But the other reason is there'll be a lot less I/O involved in hooking up 2 contacts rather than 10 contacts which you've got on each of the rotary knobs. So it's a lot less I/O. By the time you add up all the signals, if you don't matrix the contacts, you're still looking at a rather large number of I/O that you need. So I'm going to probably go along with the up-down controls, but even then I'm probably still going to run out of I/O. Well, I will run out of I/O on the Arduino, so I'm actually going to use a shift register. I've been buying some ICs for that there, so I'm going to use a shift register to shift the button information into the Arduino and just do it that way there. And then what the Arduino will then do, it will then process what the user's dialed up in terms of the voltage, and then it will then convert that to a format that the reader of the panel, reader of the EDC-501J can understand. And if we take a closer look at the actual front panel on the manual here, you can see that you've got 1, 2, 3, 4, 5, 6 banks of switches there, and they're all labelled 1248, 1248 and so on. So in actual fact, you're dialing up an MSD right down to an LSD, but you're not dialing up a digit as such, you're making it up from 1248. And there's a couple of different modes that the unit can run in terms of how it adds up or how it selects a digit from the 4 switches in the front. A little bit complicated doing it that way. I would rather just have, if you wanted 1.23456 volts, then you'll dial up 1, 2, 3, 4, 5, 6 and you'll know where the decimal point is. So that's what I'm planning on doing, obviously using the two push buttons. So the Arduino is actually going to have to convert the information that's input into a format that the edge connector on the back of the 501J can understand in order to replicate this type of data arrangement here. So that's what I'm going to do there. So let's take a look inside the unit. top of the unit's got a, it's not a solid top, it's basically a perforated aluminium sheet. There's top and bottoms like that there, so I suppose it's a rather cheap way of forming top and bottom for it. And here we are inside the unit. First impressions, it's rather clean, and it's got a tiny little film of dust over it, but there's absolutely no corrosion, and it really looks like it's been in a more or less a dust-free environment. You kind of think that with a perforated sheet in the top that you would have had all manner of dust going into it, but I kind of think the rack it's been in, there's probably something else been sitting above it and possibly below it, and it's stopped the dust getting in. And of course there's no fan in this thing here, so it's not going to drag any crap from the outside inside it, so it is rather clean. So starting at the back there, we've got, this is the output, it's an Amphenol connector there in the back there, so that's the output connector. You've got, what's this in the back here? Oh, this is the monitor connections there. Yeah, so it's basically just paralleled up onto the back of the output there so that you can monitor the output there. Got the mains connector and fuse there, and then the transformer is actually mounted on the back, as you can see. You've got the voltage selector switch there, and you've got the GPIB connector in the back there because it's GPIB compatible. A little word about that actually, you can actually connect that to there, and as long as you can implement the serial protocol, you can actually set the output voltage of the whole thing via GPIB, but I don't really want to get into serial protocols at the moment, so I'm actually just going to make use of the edge connectors down the back there, and you can actually see the two connectors going out to the back there at the back of the unit there. So I'm going to tap into them and route to the wiring to the Arduino, which I'll mount somewhere on its board somewhere within the unit. And you can actually see the one curious little thing is you've got these two edge connectors here, and plugged into them is just a couple of blanks, a couple of short blanks. Not really sure why that's been done, and unless it's just somehow to, I don't know, I mean to keep dust out of the sockets or something like that. I've got no idea, or it's obviously for some optional board to plug in there, but they've just plugged in a couple of blanks, and there's no traces on the boards themselves apart from the connector itself, but no, there's nothing there. So basically, as you can see, you got the tracks from the edge connector come along there, round the board here, right round here, and if I can just turn round there, they're coming onto these ICs here. So what you've got is any signals that you put into the back of the unit is going to come into these ICs here to be processed. And of course you've got a couple of edge connectors at the front as well, so obviously they're using the same board for the model that does have the actual controls on the front. So obviously there's going to be a board and plugged into these two connectors at the front here with all the switches and all the rest of it on the front. So in actual fact, I'm not going to make use of the edge connectors on the back. I can make use of these ones here because the same signals will be available there, so it should be pretty easy just to tap into those connectors there, and then just route my wiring up onto my Arduino, whatever that's going to go. Other than that, you've got the power supply at this side here, nice and clean, doesn't look too bad. And then down onto the main board itself, you've got all the various components and there, and I think these are just these are old styled chopper amps probably that are in these black encased items there. So I'm not going to touch the pots or anything like that. We're just going to power it up. I've just received it obviously via eBay, and the first thing I've done before I did anything when I unboxed it was change the voltage selector from 115 to 230, so no accidents are going to take place just when I put power into it for the first time. So I'm going to put power into it right now. We're going to see if it actually powers up. I can't really spend too much time trying to get a voltage out of it, because it would mean mimicking the 1248 for each digit on the front and all that kind of thing. I'm not going to get into that right now. I might make up a little test jig with some switches on it that I can plug in just to simulate the use of those switches, just so that I can get the protocol right within the software and the Arduino and all the rest of it. Make sure my shift registers are tied in properly and all the rest of it, but I'll do that later on. The first things first is just get power into it and make sure it does actually power up and there's no magic smoke. Okay, I'm a little bit further on here in my investigation of how this thing operates before I actually start hacking it and making my modifications. So what I've managed to determine, looking first at the two card slots at the back there, those were actually populated with what looked like dummy tongues, basically, maybe to keep dust out or something like that. Well, of course, I was completely wrong. What they were actually, this is a double-sided edge connector here. Both of these are double-sided. What the actual tongues were doing is they were through-hole plated from one side to the other side. So by effectively having the tongues fitted, both sides right through from one side right through to the other side, they shorted out on each one of the rows there. So that was effectively enabling this bus along the bottom here to be throughput to the rear connectors in the back of the unit. And what the idea there is, if you actually have to plug in an option card into here, like the EDC-501J card in here, you would actually remove the tongue and put the board, and that would actually then interface the signals to and from the bus here to the rear unit. So obviously, if you're not using the any optional cards, you put the tongues in. Therefore, the rear connectors are still going to work. Now, as I said earlier, I'm not going to be actually using the rear connectors at all, so I've actually just lifted the tongues out because I don't actually need them, and they're not going to interfere with any of the signals, because like I said, I'm not going to be using the back. However, I have found a use for the tongues, which is the main reason why I've disconnected them. So this is the rear of the front panel. Of course, I've got the blank version, the version that's got nothing on the front, because it's actually relying on the user using the program ports at the back here for actually doing remote selection of the voltage that you want out from the unit. So what I've actually gone ahead and done is I've actually sacrificed the tongues that were in here and moved them across over to the front here. These are shorter connectors, so I've actually had to cut down the tongues to actually make them fit these connectors here, and it actually doesn't matter that these tongues are through-hole plated for the contacts on either side. It's because the connectors, the edge connector here is actually only single-sided anyway, so both sides of that were shorted out anyway, so it's actually ideal. So I've actually hacked up the tongues, both of them, got them fitted there, and what that's going to allow me to do is actually interface onto the pads. If I can just get in a bit closer there, you can see that there's a row, there's a row of through-hole plated pads right along the top of the actual gold-plated contacts there. So I'm actually going to be able to solder my wiring off of each one of the through holes where required to take it off to the Arduino and additional circuitry that I'm going to put in. So I've actually gone ahead as well and labelled up, I've done a bit of detective work, reverse engineered some of the circuitry and found out how the original switches that would have been on the front panel and interfaced to each one of the contacts along there. So I've labelled them up accordingly right the way along, all 6 of the switches, and there is actually an extra couple of signals for likes of range select and set permanently to 0 and a front back selection bit as well, but I'm not going to be making use of them at all. I'm just going to leave them. So in actual fact, on the back of the PCB where those interface onto these ICs along here, I've actually just linked it out, so I don't actually need to put any wiring onto some of them there. So basically I'm just looking to interface to the actual switches or the data bits for selecting the voltage, so that's what I'm going to do there. I've gone ahead and actually on the powered it up. got my the output connected up. I've got the sense lines shorted out just temporarily there so that I'm getting an output, and just to make sure that the unit is actually working. And I've actually gone ahead and set the bit on the back of the board just to permanently set the output to 0 volts so that I don't have, because I don't have any switches connected obviously. So I've actually got my 6.5 digit meter hooked up now, and we'll take a look at that now. And there we go, I've got it on the millivolts range at the moment, so you're looking at what, 13.9 microvolts, 10 microvolts there. So it does seem to be jumping around a little bit, but you know, given the age that this sort of thing is, I'm still down at the microvolts level anyway, 14, 12, 9 microvolts there. So that's not too bad. I can make good use of that for the, you know, for this voltage standard anyway. So the next thing to do is to start thinking about the actual switches that I'm going to be putting on the front there. I'll probably have to disassemble this front panel because I will actually be drilling holes for the LCD and that sort of thing. So I think the next thing to do is I'll make some measurements, see what sort of height I've got here, work out where I'm going to put my Vero board when my shift registers on it and that sort of thing. I'll knock up a circuit on paper, and then I'll take the front panel off, and we'll look at to see where we're going to position all my switches, and make the final decisions of what I'm actually going to, how the functionality of how I'm actually going to do it. So that's the next thing to do. So here's the actual reverse engineering that I was doing. This is like an underside view of the 2 edge connectors at the front of the unit, where I was sort of doing some detective work to see actually how it all interfaced. And you can see that on down here I've got, this is like one IC, the underside of the PCB right along there. I mean, I know what type of IC they are, so I was able to work out sort of how it's functioning, how it interfaces. So this is my labeling here along the underside of the 2 edge connectors there on exactly what pin was used for what, you know, the 6 digits and the select and the strobe, which is a set to 0, and the range select there. So that was that there. So that took a little bit of time yesterday to do that, but overnight I decided, well, let's email Krohn-Hite, who actually make this unit, or you know, are taking ownership of it anyway. So I thought I'd just email them just on the fly there, and I wonder if they've got a service manual or a bunch of schematics. So in actual fact, the good guys over there actually sent me a service manual. It's labelled an operating manual, but it's basically a service manual, and lo and behold, look what I get inside it. A nice set of schematics. It's not the full set, it doesn't have all the options and all that stuff on it, but you know, I don't have that anyway. But you know, basically this is the front panel ICs along here that actually interface to the front panel switches, as you can see along there, and this is it interfacing down onto the DACs basically, and then you've got the final DAC output here. That sums up all the individual ones via these resistors along here, and this is the final DAC output that goes away off to the amplifier, the final amplifier stage there, and there's a, you know, a few extra bits of additional circuitry as well there. It's not the full circuit diagram, it doesn't seem to have the reference diode and all that sort of other circuitry there, but it's got this one. This is the primary one that I really need so that I can see where I'm interfacing to. And if you look closely, actually one of the ICs, it's a selectable buffer, dual 4 bits. So basically you've got the 4 bits here that come from the front panel, and you've got another 4 bits that come from the program port at the back. So M is manual, meaning front panel, P is program from the actual rear of the unit, and obviously there's a bit here that's paralleled up onto all of the ICs from selecting. You put a high signal on the pin 1 there, and it'll give you the rear panel, and low for the front panel. So that's the one I've actually shorted out to select it to low for the front panel permanently. And then you've got this other bit here which you can set, it will set all the outputs high, which really gives you 0 volts. So there's the STR input on the IC there. So a high on that will give you a 0 volts output on the DAC output, and low is for normal operation. So I'm probably just going to leave that on normal operation permanently. I don't really need to use that because I've got an Arduino, I can make the software play output 0, you know, if I want to, via the code and via the inputs there. I don't really need to use this hardware version of the same thing. I've got the interface schematic for the front panel. I've also got a little bit of a layout here for the various amplifiers, that big black things that we've seen in there. It's the various reference amps and that sort of thing. And then you've got in this case it only shows the 6 all 6 of the DACs on here from the LSD, the optional least significant one, as you can see there, and then you've got the other 5 all the way up to the most significant one there. So that's that one there, and I've also got this is the final output stage. This is the input from the DAC there, and basically buffering it with the sense lines as well, and all that's tied in, and another ready flag and all that sort of thing there that goes. I could probably make use of that as well if I needed to back into Arduino as some sort of ready indication. So who knows? We'll just wait and see. There is other schematics, but that's for the optional cards. So there's no need to show you them because I don't have any of the option cards. But it's you know, pretty good in a way that I've got the full manual here. You know, the normal operating manual is available on the web, but it's the service manuals, obviously it's exactly the same thing but with the schematics at the back. So that's very good of Krohn-Hite to send me that within a few hours of me sending an email, so thanks to them for that. Oh, and the other thing I've got, I should have mentioned, I do actually have 5 volts and 0 volts on this edge connector here. It's not on the other one, curiously, but I thought they would have put it somewhere, but at least I've got the 5 volts and 0 volts there that I can pick up. That'll 0 volts common to the interface ICs along here, so that'll allow me to power the Arduino and LCD and all that. Okay, I've done a little bit of planning, so I've decided to look into how I'm actually going to run all the wiring from the edge connectors here and also the front panel switches round the side here, because what I'm actually going to do is I'm going to mount a bit of Vero board here. There's a couple of screw holes I can probably make use of along the top there to screw the board on, and the Arduino is going to be mounted on there, and also the 6 shift registers ICs, 3 coming in the way and 3 going out the way, so they're going to be mounted there. That'll be bolted up there, and the way I'm actually going to connect them all up, because you know there's quite a lot of wires, is I'm going to use actually a ribbon cable here. So I've actually done a test wire up of the first one from the first back connectors. I think it looks actually quite neat there, and I can still read the writing underneath the wires there to see which bits what, and of course so that'll go right round there, and then similarly onto the Vero board there, and then I'll do the same again with another bit of ribbon cable for the second board coming round, and then again another bit of ribbon cable, making use of a lot of ribbon cable here from all the switches. They'll just probably just come along probably mounted there somewhere, something like that, from all the switches, and of course the LCD as well. It's going to be mounted you know, round about there, so there'll be the various connections, the 6 or so connections on the back there that'll take a little bit of ribbon cable again round onto the Vero board as well. So you know, the Vero board is actually going to be a little bit congested with ribbon cables, but I don't think it'll be too bad. I haven't worked out yet if I'm going to put a connector on it so I can disconnect the ribbons. Not really sure yet. I probably should, so that I can remove the board, but you know, once it's up and running and it's done, once it's in, so I'll make a decision on that. I might just wire up the individual wires from the ribbon cable through the 0.1 inch grid holes there and then just get it on. But you know, I don't think it'll be too bad, so it'll take me a day or something like that to get everything wired up, and the panel drilled and all the rest of it, and we should be nearing a point where I can actually test it out. So I've been stripping down the front of the unit now, just so I can prepare up the front panel and drill the holes and all the rest of it for the LCD and put the push buttons on and all the rest of it. And there was a paper strip along the front here, which and some other labels over here I thought I'd take some acetone to and get rid of, so I've just done that. And underneath the paper strip along there, I don't know if you can see that, but that says nuclear training. So I don't know where this voltage standard's been in the past, but the mind boggles. Alright, jump forward a few hours and I've moved a little bit further forward, and as you can see I've got the front panel back on with my switches all mounted, the LCDs all mounted, and I've gone ahead and used the ribbon cable that I'd bought to interface all the switches and the interface to the LCD there. Keep it rather neat, I think, by the time I sort of like run these across here and round onto the Vero board. It's going to go there, and the same with the LCD. It doesn't look too bad. And if I move round to the front now, I'll let you have a look at the front. So here it is, and LCD in the left hand side. I figured that's always better. I'm right handed, so prefer to go up onto the controls here with my right hand, and it doesn't obstruct the LCD. I did think about changing the layout of the switches, maybe just using 4 switches for like maybe up and down, and then a advanced character or advanced digit kind of affair, but I'm not a fan of that. I like direct access to individual digits, just at the press of one button rather than playing around tapping the same button over and over. So I've gone ahead and just fitted the pairs of buttons there for each digit there, so they're mounted there. And I've got an extra button in the end. I'm probably going to use that for a 0 control, so basically you can hit that and it'll 0 the output, and then hit it again and it'll latch it back to whatever was set on the switches there. So again, it's a 2x16 9mm character height LCD, so that shouldn't be too bad. And I'm going to make a use of the backlight. I think I'll have to do some checking just to make sure I've got enough current from the output of the power supply. I'm not sure what I've got available to me for my Arduino and all the rest of it. I think it was a couple of 100 milliamps. If that's the case, then it won't be a problem. I'll have enough to drive the backlighting. If not, I'll maybe think about something else, because I would like it to illuminate when it's on. I did think about getting rid of the overload button there, and maybe incorporating that as a character in the LCD, but I haven't at the moment. I've left it running, well, left it positioned where it is, and that's that. The only other thing I did think about doing was actually spray painting the whole of the front of the thing and tidying it all up. As you can see, I've still got some of that stamp that was on the panel when I got rid of that big long sticker, and there is actually some additional numbers there which were also covered by stickers, and I've got rid of them. But it's just going to be for use in my workshop, so we'll just leave it as it is. At least I've got the text right along the top. I'd have to go and reprint that and all the rest of it, and I can still read the model 501J, so that's not too bad. So the next thing to do is, we're back inside again. Next thing I'm going to do is I'm going to document all the colours on the ribbons and what's assigned to what there, and write all that down nice and neatly, so that I can then move on to the Vero board, which is going to mount here. Still not sure yet how I'm actually going to attach the ribbon cables to the Vero board. And of course I've still got over here, these are the other couple of ribbons there for the interface down onto the main board. So that actually is, it's quite a number of wires when you actually look at it. But that's what I'm going to be getting on with next. And roll on a few hours, and I've got the Vero board assembled, for the most part anyway. As you can see, I decided just to solder the ribbon cables directly onto the Vero board there. No sense in having connectors. And that's the other side there, all nicely wire wrapped there. A few hours work just to get that completed. I've got the Arduino fitted, the Arduino Nano. I've got the shift in buffers onto the sockets, but I'm still waiting on the 3 chips for the shift out, so I won't be able to get that going. And I've got a contrast adjust pot for the LCD there. I have got some code loaded just to put Hello World on the LCD, so I'll let you see that right now. But first of all, I'll screw in the PCB. Well, as you can see, the ribbon cables, I'll have them looped neatly so that they're not too bad in terms of a cable run. And you'll just a couple of screws at the moment just to hold in the Vero board, which I'll do, just nip them up a little bit there. So as you can see, let's get the camera in there. So that's them there. They're not so neat at the moment, but once I tidy them up, they're looped nicely before they come up and onto the panel there. So that's not too bad. So let me just get the camera back a bit, and I'll get some power on. Okay, and of course I'm picking up the 5 volts, as I said before, from the actual motherboard itself. And so far so good. I'm only taking a few milliamps, right enough, but even seems okay even with the backlighting on. So there we go. Just drop the camera down, and there we are. Hello world. So I'll just zoom out a bit. I don't think it's going to look too bad once it's done. So whilst I'm waiting on the shift out ICs coming, I'm actually going to start work now on the software for reading the switches. I'll just do some test code to shift in the switches, and then maybe just display it on the LCD there so I can see I'm getting some reaction and the right reaction from each one of the switches there before I actually write the code to actually output to the output buffer ICs. But yeah, that'll be the next spot to do now. The overload light is on permanently at the moment because the shift out's not working. All the the ICs are not fitted, so all the input ICs on the actual motherboard for the 501J are basically open circuit, so it's getting all manner of signals there. So it's probably going way over scale or way under scale or something like that. So that's probably why that is. But next spot, write a bit of code. Okay, I've gone ahead and done some work in the software. As you can see, I've got the LCD powered up there with a couple of bytes showing. So what I've actually done, I've actually written some software and I'm actually reading the switches now. I'm shifting the data in via the 4021 shift registers there into the Arduino, and it sits on 2 bytes. 1 byte's reading the first 8 switches and the second byte's reading the other 5. And as you can see, when I press the button here, I get a different value on this byte here from each one of the switches. And then I move to this group of 5 there, and that's the other one there. You can see that's working away nicely. It's one little bug. If you notice that this first 8 switches here are actually for this byte here, but you notice that sometimes when I press this button or a couple of the buttons there, the other byte's affected by on the other 5 switches. And what I think that is because I'm only using 5 of the 8 inputs on the IC, the other 3 are actually floating. So when you actually press a button, probably on a wire wrapping wire or something that's running pretty close, I think it's picking it up and getting a phantom digital input there. But I can go ahead and maybe short out the input on the ICs down to ground or something like that, but I'm not too worried about it, because what I will do, I will be masking off the data in the software, so even though it's a phantom number like 252, it's not a number that's going to be used anyway by any of the switches, I don't think. But it's maybe something I will look at. If I take the board off again, I'll maybe do something about it. So the next thing to do is, while I'm still waiting on the shift out registers coming, the ICs for that as well, I've got 3 surface mount ones, so I might make up a little adapter just so that I can plug them into the sockets on the Vero board, just so I can get on with the software. But there's plenty to do. Maybe they'll arrive tomorrow, I don't know. But there's plenty for me to get on with anyway, in terms of writing a bit more software on processing the data now from those 2 bytes in readiness for sending out on the shift out registers. So there's plenty still to do. Okay, we've moved on a bit again, and just to show you the workshop, well, the workbench anyway, with this particular project, this is kind of what happens when you end up reverse engineering something like this and trying to extend its capabilities with some modern technology. So as you can see, I've got the EDC-501J sitting in the workbench there. I'll be up on its side. Round there I've got my scopes and all the rest of it, right round to the Arduino code sitting on the screen there. So it's been quite a job to get to this stage so far, but I think I've made a little bit of advancement in terms of getting it the functionality of the Arduino and all the rest of it. The diagrams I got weren't complete. They were different in areas compared to the actual unit, so it caused quite a bit of headache to get it to where I've got it now, including putting jumpers in the back of the board and all the rest of it to disable certain functions which I can't use, partly due to not having the right information on the back for the edge connector at the back and how to link out certain functions and disable certain functions. and if I don't want certain functions, the easiest way to actually disable them is actually to remove some parts. So there's like plug-in amplifier modules there which I've unplugged, and so I've kind of got to a stage now where I have actually got something running. So basically I've got the front panel. I'll just turn it around there so you can see it. So there's the actual front panel itself, and as you can see there is actually something showing on the display there. That 6 digits there are reflective of the 6 push buttons, up and down push buttons on the front panel. And if I just pan up here up onto my bench meter here, my Keithley, that's the actual output voltage from the from the unit itself. So more or less 0 volts at the moment for 0 on the display. And if I just come back around here, sorry for the funny camera angles, and I've kind of got one working at the moment. Not sure why the other ones are not working, but I've got this one working here. So if I just press this button here, there we go. That's 03000. That's actually 0.3 volts. I've kind of dialed in there, and if I go back up onto the display here, the meter, there we go, 0.299961 volts. So that's pretty accurate there, and it seems to be fairly stable right down at that last digit there, so it's not too bad. Probably slightly out, but that could be my meter as well. This is a kind of an eBay meter that I recently purchased, so I'm not sure how accurate it is. I've really got nothing to compare it against. So that's 0.3 of a volt there. So if I just come back down again, and then I'll just press the button here if I can show you. So I'll press the button there, it's 0.4, 0.5, all the way up to 0.9 of a volt there. So I've dialed that up there, and then we're back onto the display here, and there we are, 0.900026. So that's not too bad. So if I just change the range, see what I've got it on there. I have actually got it on the 1 volt range already, so that's the maximum resolution I'll see at that. So that's not too bad at all at the moment. So the next stage is to get the rest of them working. Of course the push buttons are actually working. I can actually press these and it will affect the display. I'm just not getting anything on the output. I'm not sure why that is at the moment. Basically each one of those switches there controls via this hardware in here 6 different DACs effectively. So the one that's working at the moment will be this one here. This is your most significant all the way down to your least significant up there. So this one will be the one that's working now. So probably if I was to monitor the output voltage of that there, I'll be able to see that change as I increment the push button there. Not really too sure exactly how those work internally. Haven't been able to find anything on the net at all for them. 3 of them are marked AD-550LDs, the most significant ones. The least significant ones are marked AD-550KD, so I can only presume there's a slight difference there. I don't think it's just a batch number that's maybe different for those 3, because I have seen internal photographs on the net of other people's units and they have the same gold coloured ones there, and then the darker, traditional package ones there, so the plastic packages or whatever they are, and they're the same. So I can only suspect that maybe the least significant ones are a slightly different spec than the most significant ones. So the next job is to try and get the other digits working and make, see how far we get there. The only other thing that I did forget to do on the Arduino board down here, which is obviously running, I forgot to pull up resistors on the switch inputs there, so I've actually just gone and hacked them onto the back here with a 5 volt rail along the top. So that'll do. No one's going to go in there, it's only for me really, so that's where we are. So back on it again and I'll see if I can get the other switches working. Okay, a good bit further on now. I've done quite a bit of changes to the software. There was a few software bugs with Arduino which was causing some of the buttons not to operate properly. So I think I've got that sorted out, and it seems to be working quite well now. Still got some bells and whistles to do on the LCD and put some labels on the front panel there to better label the switches, the push buttons there. But I thought I'd just run through the functionality, the basic functionality that I've got so far on the unit. I've got my 6.5 digit multimeter hooked up to the output here, and we'll just run through and see what sort of accuracy we're getting. Okay, it's calibrated for 0 to 10 volts, and the way I've done it here, obviously most significant at this end and least significant at that end, but the way I've laid out the LCD is it'll go further than 9.9999, it will roll over to 10. So if I just go up, hit the up button there, in terms of volts, well I'll just stop at 2. So you see you've got more or less 2 volts up on there, a few microvolts out, but we'll go all the way up to 10. And you see as I roll over from 9, I've got it so that the digits shift to the right so I can see 10 on the display there. And obviously I can put it back down. So that's the most significant digit there. The next one there obviously, let's go up to 2. So you got 0.2 of a volt. And then all the rest as well, 0.03 there. 0.003. 0.0004, and then the last digit, which I had to wait for it to settle, so there we go, 4. So that's tens of microvolts there that you're getting at the end there, on the last least significant digit there. So that's tens of, so it's not too bad really for an old device like this. So there we go, it's just 1 digit out there. So if I just dial up a random voltage, 4.63156, 4.631, slightly out. I suppose there's a linearity error in this old device here, the way it does the D to A conversion, but otherwise I'm quite happy with that. The yellow button at the end will just instantly zero the output, so just hit that there. There we go, and it instantly zeros, and you've got to go back to set the voltage again. So that's about it really for this programmable DC voltage standard. Not much more I can do to it apart from, like I said, adding some bells and whistles. I could probably think about maybe adding a timer in so that when you power up it'll give you a countdown timer for maybe 10-15 minutes or however long it takes for it to stabilise inside. But whether I go and bother doing all that I'm not really sure. I think the next thing I will do is just start labelling up the buttons a bit better. They're kind of intuitive, but it's nice to know that you can go direct to millivolt, you know, for quick of easy use, you know, getting direct to the digit you want. You know, because what I wasn't able to do was put the LCD at the top, maybe arrange the buttons down below each digit. I didn't really have the room in behind the display for that because the internal PCBs come up so far, so the bottom half was kind of out of bounds really. I just managed to squeeze in the output here. The only other thing I haven't done, I didn't really see the need for what I'm going to use it for, and that was putting the sense inputs on the back as well, on the front as well. They remain on the back, I couldn't be bothered moving them. So that's it. So if you like the video, give it the thumbs up, and thanks for watching.